Hello everyone, I'm Paul and today we're solving problem 3100 water bottles 2. This is a medium one that's very similar to part 1, so next I will show you my thought process and efficient solution. If you haven't seen part 1 yet, I recommend you to go and watch that video, it's in my channel. We are given two integers, num bottles and num exchange. Num bottles is the number of full water bottles that we are given initially, and num exchange represents the amount of empty bottles that we can use to receive one full water bottle. Our job is to return the maximum number of water bottles that we can drink. So let's say we are given this. Let's say num bottles is 13 and num exchange is 6. And one thing I didn't mention is every time we use num exchange to get a new full water bottle, we need to increase num exchange by 1. So with this example, we start with a result of 13. We drink these 13 water bottles right away. Now, what's my thought process? As soon as I see something like this, I try to run a simulation. And here we have the constraints. We know that num bottles is smaller or equal to 100 and the same for num exchange. So these are really small values. So let's try to imagine what's happening here. If we drink 13 water bottles, now we have 13 empty bottles. So we have 13 empty bottles and we know that num exchange is 6. So let's think in small terms. Let's go slow. Let's take 6 bottles, 6 empty bottles, and exchange those with one full water bottle. So here remaining bottles are 7. We need to add 1 here, so this is 7. Remember, whenever we use num exchange, we need to add 1 here, so this is 7 for the next time we are using this. And now we have a new full water bottle, so we can add 1 to the result, and given that we are consuming this, we can add 1 to empty bottles. So this is 14 and this is 8. And this is the key observation for this problem. We are going step by step here. We are taking the minimum amount of empty bottles given num exchange to get a new full water bottle, so we can add 1 to the result and 1 more to empty bottles, and we repeat the same process until the number of empty bottles is smaller than num exchange. Now we have 8 empty bottles and we can repeat the same process. We can take 7 empty bottles because this is 7, and now we have 1 empty bottle left, and with these 7 empty bottles we can get 1 full water bottle, so we add this to the result, and we are adding this new water bottle as an empty bottle also, and this is now 15, and this is now 2, and this is now 8, because we need to add 1 every time we use this. And now we have only 2 empty bottles and num exchange is 8, so we can't exchange these 2 bottles, so we return the result, which is 15. So this is the entire approach. Here time complexity will be roughly big O of 1, and I say roughly because the number of bottles and num exchange is different for every test case, so this is not technically big O of 1, but it's a very fast algorithm because these constraints are very small. So with this in mind, let's go with the code. First, we are drinking num bottles right away, so we can say our result is num bottles. And now while num bottles is greater or equal to num exchange, meaning we have the minimum amount of bottles to get a new full water bottle, we subtract from num bottles the minimum amount of empty bottles to get a new full water bottle, so we subtract num exchange, and now we have to add 1 to num exchange, and now we have a new empty bottle, so num bottles plus equal 1, and we add 1 to the result. Finally, we can return result. So this is the entire code. Now let's submit this and see if it works. As you can see, this works and it's very efficient. So if you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.